Okay, so let's have a look at some past paper questions for some chromatography. So this basically tells us about paper chromatography. It's got an equation to show you the RF, which we're going to use in this question. And also it tells you about a pentapeptide, which means a peptide of, a molecule with 5 peptides in it. It's asking here why only 4 spots were obtained on the chromatogram of the hydrolyzed pentapeptide. Now, if I told you that had 5 amino acids in it, then you would maybe expect to see 5 spots on the chromatogram, each for the peptide. However, there's 2 answers that this could possibly be. Either 2 peptides the same RF, so that means they travelled the same distance, and that can sometimes happen. And then also 2 peptides could have been the same. So they could have been repeated. The peptide or the pentapeptide. So you could have had that peptide come up twice. Also, for this next one here, it's showing you this. It's telling you that the RF value for methionine is 0.4. Draw a circle around the spot on the chromatogram that corresponds to methionine. Well, what we need to do is we need to use the RF values to work this out. So RF is going to be the distance of our thing, which we'll call X, divided by the solvent front. So what we'll do is we know that RF is going to be 0.4. Let's measure the solvent front. So I'm going to use a wee ruler here, and I'm actually going to put this in here. So that's where we started off, and then we're going to go to the top. So that is going to work out at about 7.5 centimetres. So if we wanted to try and work out X, it's going to be 0.4 times by 7.5. I'm just rearranging that equation. If we work that out, that gives us 3 centimetres. If I then go back to my chromatogram, put my ruler in, then when I go to 3 centimetres, which is about there, it's obviously this spot here. And that's how you answer that one. So it's about a wee bit of problem solving, rearranging equations there for you. Okay, let's try this one. Let's identify the amino acid that corresponds to spot 1 on the chromatogram. So this is going to be spot 1 here. I'll colour that red with my pen. Let's work this out. So we will have to work out the RF value for this spot 1 to tell us which one it could be. In fact, you don't even have to do that. A simpler way to do this, you know it's the one that's travelled the furthest, so it's going to have the one with the greater RF value. So that answer here is going to be tyrosine. Okay, that was actually a lot easier. Then it says the retention factors for each of the amino acids in the solvent 2 are shown on the table. So what we need is we are trying to work out spot 2. The spot on chromatogram 2, which actually talks about alanine. So this is a wee bit tricky because we need to use information about what we had last time. So alanine would have been one of these ones in the middle. Because it travelled 0.51. And as you can see, that's got 2 that have the same. So when they do the 2D chromatography, then that's going to split into 2. So it's going to be one of these 2 here. However, they now have different RF values when you had started from here. So what we're going to have to do is we're going to have to basically work out kind of which one it would be. So alanine has got 0.21 and threonine is 0.34. They were the two ones that were at that same spot. So alanine is going to be the one that travels the least far out of these. So this one here. In fact, I'm going to rub this out. Oops. This one here is alanine. That's quite tricky because you've got to use information from two parts of the question. So the reason for this is, so explain why only 3 spots are present in chromatogram 1, while 4 spots are present in chromatogram 2. Well, the answer for this one is because 2 of the amino acids had the same RF. Travelled the same distance. One mark. However, when placed in a different solvent, this spot separated two spots. That is because there was 4. So we've been able to separate them when we put them in the different solvent. Second mark. There you go. That's the answer for this. Okay, so a chemist analysed a mixture of 4 dyes, A, B and C, and D using gaslit chromatography. When a polar column was used, the following chromatogram was obtained. So you're going to want something that is going to be which one was present in greatest concentration. So the one that I would say was in greatest concentration would be this one here. But if you want to think about this, then if it's a polar column, then one that is going to be polar would stick to it longer. So these ones, so this one would be most polar because it would take the longest to come out. More polar things take longer to go through a polar column, and this is going to be less polar. So they're going to stick to the inside of the column less, so that means that it's going to travel less quick. So if we look at this, we can have a think. So we are going to want something that is the second most polar. So I'm going to take this one out and say that this is the least polar because it's got no OHs. I'm going to say that this is the second, so this is going to be the next one because it's got more OHs. That one. So that's C. So this one had no OHs. This one only has 2. This one now has 3 OHs. So I would say that's even more polar because you've got more hydrogen bond there because of the OHs. So that one is going to be D. That's going to be the answer. And then this has 1, 2, 3, 4, 5, 6 OHs. That must be A. And you can see that's a big difference in the number of OHs. 3 at D, 2, 6 at A. That is also a big difference in time there as well. So the correct answer is going to be D for that one. When forensic scientists analyse illegal drugs, anaesthetics such as lidocaine are sometimes present. This shows you the chromatogram from an illegal drug. And this is one of the questions. It says the structures of benzocaine and tetracaine as shown below suggest why benzocaine has a shorter retention time than tetracaine. So if you look back here, Benzocaine is A and tetracaine is E. So tetracaine has a much longer retention time. So why does benzocaine have a much shorter retention time? We could say that it is a shorter molecule, so it's a much smaller molecule. There would be much less LDFs. This does not stick to the column as much. Therefore, shorter retention time. I should mention as well that this answer would give you 1 mark, this answer would give you 1 mark, and this answer would give you 1 mark. And that's all of them can explain why there's a shorter retention time. This is only worth 1 mark as well. So if you said one of these ones that have got a tick, then you would have got that mark fine. Okay. Why is it difficult to obtain accurate values for the amount of lidocaine present in a sample containing large amounts of caffeine? Well, if you look here at B and C, caffeine is C and lidocaine is B. If you had large amounts of caffeine, and because its amount tells you it's basically the area underneath the peak, if it's a higher peak, then there's going to be more of it in it. But what actually happens is because those two are so close in retention time, if you had a large amount of caffeine, then that could actually overlap and could maybe look something a wee bit like that. You wouldn't actually know which one it's referring to. So it's because they're so close together. It's because they overlap. So it's because the two peaks overlap. Okay, next one, what would be the difference in the chromatogram if there was only half the amount of tetracaine present? Tetracaine is E, well the area under the curve would be half, or the peak would be half the height. When methanol and ethanol were analysed by gas liquid chromatography, it was found that methanol had a longer retention time. Explain why methanol was retained for longer in the GLC column. So if I put methanol here, which is this, and I put ethanol, well, methanol has a hydroxyl group. So that's more polar. And that is more polar than ethanol. This means it would stick to the column more, or it would be attracted to the stationary phase. That means it would have a longer retention time. There you go. Hopefully these make sense. I've got some past paper questions in the file. What your teacher will do is, it's not to do all the questions because there's some for different topics, but your teacher will give you a list of the questions that we need to do for chromatography. Thank you.